Hi everyone, it's Miss Costa here, and in this video we're going to go through a predicted paper for what might come up tomorrow. Obviously none of these topics are guaranteed to come up, but it's just a best guess based on past papers. And I have made it a little bit harder than it probably will be tomorrow, but that's just so that you can practice all the hard questions and then tomorrow will be an absolute breeze. Okay, so for question 1, I've been told that A is made up of 2 squared times by 3 times by 5 cubed, and B is made up of 2 cubed times by 3 squared times 5. And they're asking me to find the highest common factor of A and B. Now, if I was being asked that normally, what I would do is list the factors of each number. I could do that by just listing the factor pairs, or I could have used a factor tree, and then I would have got their prime numbers. However, I can't use this method, but I do have another method that I could use when I don't know the numbers, and that's the Venn diagram method, where one of the circles represents all the numbers that multiply to make A, and the other one represents all the numbers that multiply to make B. And in here, we put any number that is common to both. So if we just write them out, 2 squared means 2 times 2 times by 3 times by 5 times 5 times 5. And B is made up of 2 times 2 times 2 times by 3 times 3 times 5. So I'm looking for any factors they have in common. So 2 is the first thing they have in common. I write that in the intersection. I only write it once because it's the number they both have in common. They have another 2 in common, so I'm going to write another 2 here. Then they've got a 3 in common, so I'm going to write that here. And then they have a 5 in common as well. So all of the factors they have in common are in this intersection. And to find the highest common factor, I just multiply all the numbers in the intersection. So I'm going to do 2 times by 2 times by 3 times by 5. 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So the highest common factor is 60. Now I can finish off my Venn diagram to find the lowest common multiple. So the numbers I haven't used are 5 and 5 for A, and then I haven't used 2 or 3 for B. So I now know that this intersection here, all of the numbers in here multiply to make 60, and to find the lowest common multiple, I multiply all of the common factors. So I'm going to do 5 times 5 times 60 times by 2 times 3. So let's just simplify that as much as we can. That would get me to 120, and then 120 times by 3 is 360, and 5 times 5 is 25. So I just need to work out what 25 times by 360 is. Now you can just do any multiplication method you like. I like the lattice method just because it means you only ever have to multiply 2 single digits by one another. So we just draw a 3 by 2 grid because it's a 3-digit by a 2-digit number, and then I multiply, and in the top part of the box I write my tens, in the bottom part I write my units. So 0 times 2 would be 0, 2. 0 times, oh no it wouldn't, 0 times by anything is 0. So 0 times 5 would be 0. 6 times 2 is 12, 6 times 5 is 30, 3 times 2 is 6, and 3 times 5 is 15. Now when I've done that, I just go along my diagonals and I add everything that is in each individual diagonal. So the first one is 0, the second one is 0, then I've got 5 plus 3, which is 8, plus 2, which is 10. So I carry the 1 into the next column. Then I've got 6 plus 1 plus 1 plus the 1, so that would be 9. So therefore, the lowest common multiple of A and B is 9,000. Okay, the next thing I have is multiplication and division with decimals. Now there's a really cool division fact that you should know, and that is, if I had a simple number like 6 divided by 2, that would give me 3. If I then multiplied both parts of the calculation by the same power of 10, so 60 divided by 20, the answer is also 3. If I did that for 100, 600 divided by 200 is also 3. So therefore it follows that 0.6 divided by 0.2 would also be 3. So I can use this division fact to help me with decimals. So what I want to do is I want to keep multiplying until I have a nice number to divide by. So if I times it by 10 first, that would give me 4.32 divided by 0.12. Not so nice. Let's times it by 10 again. That would give me 43.2 divided by 1.2. Still not an integer, still not 2 whole numbers. If I times it by 10 again, I'd be left with 432 divided by 12. Now I've got some integers, and if you're great at long division, you just do that. But if not, and this is a key division fact, especially for the non-calculator paper, if you don't know how to do the division, turn it into a fraction, because that's all division is. That line here, divide, is what this line here means, divide. So I can then simplify it until it's a number that I'm comfortable with. So 432 divided by 2 is going to be 216, and 12 divided by 2 is 6. And again, if you need to divide by 2 using the bus stop method, absolutely do that. Then I can divide by 2 again. So the first thing I did was divide the fraction top and bottom by 2 to keep it equivalent. Then I can divide by 2 again if I wanted to, so that would be 108 divided by 3. You could have, when you got to here, just use the bus stop method, but why not make life even simpler? So I'm going to do 108 divided by 3. 3's into 1 don't go, so 3's into 10 go 3 times, remainder 1, and 3's into 18 goes 6. So that must be 36, using this division law, that as long as I've multiplied both parts of the calculation by the same power of 10, the answer will be the same. Now for multiplying decimals, it's slightly different. The first step you want to do is turn it into whole numbers and multiply like that, but then you want to be mindful of what you've multiplied by. So to turn this into a whole number, I'd times 5.3 by 10 to get to 53. I'd need to times this. Well, if I times it by 10, it would be 7.25. If I times it by 100, it would be 72.5. If I times it by 1,000, that would be 725. So in total, I've multiplied this calculation by 10,000 to turn both of my decimals into integers, whole numbers. So then I'm going to do 53 times by 725. And again, you use whichever method you feel most comfortable with to get the multiplication done. I'm going to just use the lattice method because I like it and I think it's fun. So you divide it into 2, and then 5 times 5 is 25, 5 times 3 is 15, 2 times 5 is 10, 2 times 3 is 06, 7 times 5 is 35, and 7 times 3 is 21. Now I just add all my diagonals, so that would be 5. 5 plus 1 plus 6 is 12, so I carry the 1. 2 plus 1 plus 1 is 4. And then 5 plus 2 is 7, 8, and 3. So I know that 53 times by 725 is 38,425. Now, unlike decimals, that's not the same calculation. I don't get the same answer. What I have to do is think either, this is the shortcut method, you count how many digits are after the decimal point in your calculation. So there's 4 digits after the decimal point in your calculation. So you just say, okay, 1, 2, 3, 4. I'm going to put the decimal point there. So 5.3 times by 0.725 is 3.8425. Or the proper way, but you're probably just going to use a shortcut way, is this once is the calculation once it's been multiplied by 10,000, so you divide by 10,000. Shortcut way is probably the best bet for now. Okay, so in this question, we've got a few of the index laws. I'm being asked to write down 17 to the power of 0. Really quick recap. Let's just use a 2 power of 2. What do I do? Well, 2 squared is 4. 2 to the power of 1 is 2. Each time I'm dividing by 2, so I need to follow this pattern. Therefore, 2 divided by 2 is 1. And this is going to be the case for absolutely anything. So 17 to the power of 0 is 1. Anything to the power of 0 is 1. So that is a super easy mark. Anything to the power of 0 is 1. Next, we've got 7 to the power of minus 2. And what this means is you basically want the reciprocal. So imagine 7 without the minus is 7 squared. The reciprocal of that would be 1 over 7 squared. Okay, so the negative sign just says write it as 1 over itself without the negative. And I'm asked to write down the value of it, so I need to work it out. So that is going to be 1 over 49. Now for the next question, I'm told to write 27 times 3 to the power of 9 as a power of 3. So that means I need to write 27 as a power of 3. So what's a 3 kind of time? 3 to the power of 1 is 3. 3 squared is 9. Then 3 cubed is 27. So I know that 27 is the same as 3 cubed. So I then just do the calculation. When I am multiplying powers, so really quickly, like a to the power of 2 times by a to the power of 5 is going to be a2 plus 5. When you're multiplying, you add the powers, okay? So you add them. So that's going to become 3 to the power of 3 plus 9, which is 3 to the power of 12. Okay, so in this question, I've been given a Venn diagram, and I'm told that the universal set, this strange little squiggly symbol, just means the universal set. It means everything that can possibly be in the Venn diagram. So it's helpful to list out what that is. So numbers between 1 and 20 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now the numbers that are in set A are multiples of 3 or 5. So let's start with the 3 times tables. That would be 3, 6, 9, 12, 15, and 18. And then the 5 times tables, well, that's 5, 10, 15, and 20. Okay, so in set A are going to be all of these numbers. And then set B is the factors of 20. So I could just do a quick little factor tree. So I know that would be 1 times 20, 2 times by 10, and 4 times by 5. So the factors of 20 are 1, 2, 4, 5. So 5 gets circled twice. So let's be mindful of that. 10, which also gets circled twice, and 20, which also gets circled twice. So the numbers that get circled twice are what are in the intersection. They are common to A and B. So I'm going to write 5 and cross it out just so I don't forget, 10 and 20 in this intersection here. Then everything else, all the numbers that are part of A, I've circled them in a different colour so I can conveniently just write them in. That would be 3, 6, 9, and let's cross them out, 3, 6, 9, 12, 15, and 18. And then the numbers that are just factors of 20, so they're the dark green ones, that would be 1, 2, 4, and is there anything else I've circled? No. So what that means is that all of the other numbers have to go on the outside. So I've got 7, 8, 11, 13, 14, 16, 17, and 19. Okay, in total there are 20 numbers. So you might just want to double check by seeing if there's 20 numbers in there. And that's how we'd fill out the Venn diagram. Now the next part is saying list the members of A union B. Now, really quick recap on probability notation. If you've got this, that means the union. So it essentially means in your Venn diagram, everything that is in A or B or both, okay? And I tend to sort of, just a silly little way to remember it, union looks like a valley. It doesn't really, but you can imagine it being valley. Valleys in this country are very common. So it's very common. So it means lots and lots of things can be present in it. The other type of notation is this, a intersection. So that is the intersect. So it essentially means anything that is in A and B. So it has to be in both of them. So that is just going to be anything in that little intersect there. So I am being asked to list the members of A union B, so everything that is inside here. So that would be 3, 6, 9, 12, 15, 18, 5, 10, 20, and then 1, 2, 4. Okay, so everything that's in that little bit there, that is the union. And then I'm asked or told a number is chosen at random from the universal set. The universal set just means everything in this Venn diagram. And I know that there's a total of 20 numbers, so I know it's going to be out of 20. This thing here, if you see P and then something, that just means the probability of and whatever's in the bracket. Now, the last thing about a set notation is if you see something like this, that means not. So the probability that it is not in B. So B is over here. So I want the probability that a number is not in B, so I can just cross those out. And then what am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So the probability of a number not being in B is 14 over 20. Okay, so next I've got a percentages question. I'm told that the price of a festival ticket increases by 30%, and the new ticket price adds £99 to the total cost of the festival ticket. So therefore, I know that 30% is equal to £99. Work out the price of the festival ticket before the price is increased. So if I know that 30% is equal to £99, what I can do is just find 10%. And how do I do that? Well, 30% divided by 3 gets me to 10%. So I'm going to divide this side by 3 too. So I know that 10% is £33. If I know that 10% is £33, I can then find what 100% would be. I'd multiply 10 by 10 because that gets me 100. So I have to multiply this side by 10 as well, and that would be £330. Okay, so in this question, there's quite a bit of information. Whenever you see anything in a question, please, can you just write down what you know about it before you panic? So especially worded questions, I know some people are just like, So what do you know about the mean? How do you find the mean? The mean is the sum of all the values divided by the number of values. Okay, so before we even start, we have that in the back of our mind. Now I'm told that a class has 27 pupils. All 27 pupils took a maths test, and there are 12 boys in the class. Okay, so first things first, if there are 27 pupils and there are 12 boys, that must mean that there are 15 girls. Okay, so you can just work out that little bit of information. The mean score of the class was 52. Okay, I've been given some information about the total mean. So 52 is the sum of all the class values divided by 27. So what I can do is, in order to find out what all of the class values were, I would do 52 times by 27. So 52 times by 27. 2 times 2 is 0, 4. 2 times 7 is 14. 5 times 2 is 10. 5 times 7 is 35. Add the diagonals, that will be 4, 10, 4, 1. So I know that the sum of all the class values is 1,404. I'm then told that the mean score of the boys was 42. So the mean, 42, equals the sum of the boys' scores divided by, and how many boys were there? 12. So I could do 42 times by 12. And then 2 times 1 is 0, 2. 2 times 2 is 0, 4. 4 times 1 is 0, 4. 4 times 2 is 0, 8. So add the diagonals, that would be 4. 8 plus 2 is 10. 4 plus 1 is 5. Okay, so the sum of the boys' scores is 504. Okay, now that I know what the sum of the boys' scores are, and I know what all of the scores add up to, I can work out what the sum of the girls' scores must be. So 1,404, take away 504, 4 take 4 is 0, 10 takes 0, 0 takes 0 you don't need to do, 4 take 5 you can't do, so that would become 14 take 5, which is 900. Okay, so now I know the sum of the girls' scores. I also know that there are 15 girls, so I can use my mean formula to find that out. So the mean is going to be 900 divided by 15. And remember, non-calculator, the little trick is you just keep on simplifying the fraction. So I could divide everything by 5. Again, if you're like, I don't like division, just use the bus stop method. How many 5s go into 9? 1, remainder 4. 5s into 40 are 8. 5s into 0 are 0. So that would become 180 divided by 3. And 180 divided by 3 is 60. So the mean score of the girls is 60. Okay, so a slightly tricky question. The likelihood is that you will get given the formula for pressure, but just in case, the formula for pressure is force over area. So I need to bear that in mind because this question is asking me to find the pressure. I've also been given a cone. Now the formula for a cone, if you just try to like imagine that you extended it and you turned it into like a cylinder, hopefully you can see that roughly you could fit, I mean, I've drawn this really badly, 3 cones into it. So what we do is we just say it's a third times by pi r squared, because that's the base, times by the height. So volume of a cone, you could rewrite it as pi r squared h over 3. You rewrite it in whatever way is best for you. So let's see what we can do. I know that's the formula for the volume of a cone. I've been told that the volume of the cone is 80 pi over 3 and it has a height of 5 centimeters. So how do I work out the volume of a cone? I can substitute my things in. I know that the volume, 80 pi over 3, is going to be equal to pi times by r squared, which I don't know, times by the height, divided by 3. So what I can do is rearrange it in order to figure out what r must be. Well, step 1, if I times both sides by 3, if I'm timesing something by 3 and it's being divided by 3, then it just cancels itself out, because that would become 3 times by this, and then 3 and 3 would cancel. So that would be 80 pi equals pi times by r squared times by 5. Then what I could do is divide both sides by 5. So 80 pi equals 80 divided by 5. My brain is very tired. 5s into 8 go once, remainder 3. 5s into 30 are 6. Okay, so 16 pi equals pi r squared. So therefore, and you don't need to do this really, r squared is 16 and the radius is 4. But all you need to know is the area of the base, because whenever we're dealing with pressure, you're doing the force divided by the area that comes into contact with the surface. So that's just the base of the cone. So you could have just left it as 16 pi because you know that is the area. But if you needed to, you could have worked out the radius and then just done pi r squared and you'd get back to 16 pi. So I know that the area of the base is 16 pi centimeters squared. So thank you, volume of a cone, for that piece of information. So the area is 16 pi centimeters squared, and I am told that the cone exerts a force of 160 newtons. And how do I work out pressure? Well, pressure is force, which is 160, divided by area, which is 16 pi. So if these kinds of things confuse you when you've got a fraction like this, you can just split it up into 2 fractions. So the numerical part and the random pi part. So you could just split that up like that, because as long as they're being multiplied, you can split the fractions up, because multiplying fractions, what would that turn back into? It would turn back into this. So you can split them up just to make it a little bit easier for yourself. 160 divided by 16. Once again, if you don't notice that it's 10, then what would you do? 160 over 16, you divide by 2, so that would be 80 divided by 8, and then hopefully you notice it's 10. Don't panic. If you get something like this and your brain just freezes, just simplify with the fractions. So that would give me 10 over 1 times by 1 over pi. So that would be 10 over pi. Now, this kind of question, let's just write that. So 10 over pi centimeters squared is the pressure. And sometimes people are like, oh, this question is super hard, or it's doing difficult things, so I can't do it. But just do as much as you can and try and think of the simple multiplication division tricks that you can use to help you. And a key knowledge of fractions is really, really vital for so many of these. But hopefully that helped. Okay, so in this next question, I've been given a graph and told to solve the simultaneous equations. Now, they want you to do this graphically. Don't try solving them. Just look at the graph. And the way that you solve simultaneous equations graphically is you literally look for the point where the two lines intersect. So all I need to do is try and find the coordinate of that point. Where do they intersect? Over here at the coordinate -1, 1. And every coordinate is written x and then y. So x equals 1 minus 1 and y equals 1. And that is literally all you have to do. Whenever you're solving anything graphically, just look where the lines intersect. Okay, so in this question, I've been told that circle A has a diameter of 20 centimeters. Circumference of circle A to the circumference of circle B is in the ratio 2 to 5, and I then need to work out the area of circle B. So in this question, it's really helpful to think back to the formula for circles, circumference and area. So the formula for the circumference of a circle is pi times by the diameter. This is also going to be on your formula sheet, so you can use that if you don't know this off by heart. And the formula for the area of a circle is pi times by the radius squared. So it's just really helpful to just write out the things that you know so that they can help you in the question later on. So I know that the circle A has a diameter of 20 centimeters. How do I find the circumference? Well, the circumference is going to be pi times by the diameter. So the circumference of circle A is 20 pi. I know that the circumference of circle A to circle B, so A to B, is 2 to 5. So if the circumference of circle A is 20 pi, that must mean that the circumference of circle B, what have I done to 2? I've multiplied it by 10 pi. So I'm going to have to do the same on this side. So the circumference of circle B would be 50 pi. So I know the circumference of B is 50 pi. Now, how do I find circumference? It's literally pi times by the diameter. Therefore, I know that the diameter of B is 50. Now, I need to work out the area of the circle, and in order to work out the area of the circle, I need to find what the radius is. The area is pi times the radius squared. Now, just as a quick recap, the radius is the line from the center of the circle to the outside, and the diameter is a line from one side of the circle to the other going through the center. So a diameter is 2 lots of the radius. So now that I know that the diameter is 50, I know that the radius of circle B is going to be 25 centimeters. So I can use that in my formula and find the area, and I leave my answer in terms of pi, so I don't need to worry about pi. So what am I going to have to do? I'm going to have to do pi times by 25 squared. So really quickly, 25 times by 25, you can multiply this however you like. You might also know that it's 625 because you're great at your square numbers, but if not, then 5 times 2 is 10, 5 times 5 is 25, 2 times 2 is 4, and 2 times 5 is 10. Extend your line, so that'll be 5, 2, 6. Okay, so I know that the area is going to be pi times by 625, which is 625 pi. So all of these things you know how to do. It's just about recognizing what formulas do you already know and how can you use them in these questions. And that's how you need to attack all of the questions. What do you know and what can you use? At least you can pick up some marks for some of the simpler things. Okay, so here I've been told that I have a sector of a circle with radius 3 centimeters and an area of 1 4/5 pi. I need to work out the size of the angle XYZ. Well, what are the formulas that I know for sectors? I know that the area of a sector is theta, which represents the angle, over 360 times by pi r squared. And the reason for this is you're just saying what fraction of the circle am I working out? Like if I had to work out a quarter of the circle, I would use the formula pi r squared and I'd divide it by 4, which is the same as multiplying by a quarter. So we're always just trying to figure out the fraction of the circle which is this, and then we multiply that by the area of the whole circle. So let's fill out the information I know. I know that 1 4/5 pi is the area. So just to make life easier, I can turn it into an improper fraction. 5 times 1 is 5 plus 4 is 9. So 9/5 pi is the area of the sector. And I know that theta over 360 times by pi r squared. Do I know the radius? They've told me that the radius is 3 centimeters. So I'd say 9/5 pi is theta over 360 times by 3 squared is 9. So that would be 9 pi. So let's simplify that a bit. 9 pi over 5 is equal to theta times by 9 pi over 360. And I've just simplified that because that would just be 1. So I can bring the numerators together. What can I now do? Well, I can multiply it by 360. So 360 times by 9. So 360 times by 9. 9 times 0 is 0. 9 times 6 is 54. And 9 times 3 is 27. Add the 5 is 32. So that would give me 3,240 pi over 5 equals theta times by 9 pi. There are loads of ways that you can continue this. You just do whichever method works best for you. I could first of all simplify 3,250 divided by 5. So let's start there. So 3,240 divided by 5. 5's into 3 don't go. 5's into 30 is 6, remainder 2. 5's into 20 is 4, remainder 4. And 5's into 40 is 8. So let's rub that working out from, something strange has happened. Why has my slide gone? So my slide just strangely disappeared there, but let's continue. So 3,240 divided by 5. 5's into 32 go, I already did this, didn't I? Okay, anyway, 5's into 32 go 6, remainder 2, 5's into 20 go 4, remainder 4, and 5's into 40 go 8. So I'm left with 648 pi equals theta times by 9 pi. So what could I do to find out theta? I can divide both sides by 9 pi. So that would get me 648 pi divided by 9 pi equals theta. Pi divided by pi cancels out, and then I'm just left with 648 divided by 9. 9's into 6 don't go. 9's into 64 go 7, remainder 1. And 9's into 18 go twice. So therefore theta is 72 degrees. Remember, theta is just another, it's a mathematical symbol for an angle. So theta is 72 degrees, or you could say angle XYZ equals 72 degrees. Okay, for the next part, I haven't actually read this yet. Let's see. So the ratio PY to XY is 2 to 3. Okay, so I know that XY is 3. So PY is going to have to be 2. That's quite a nice ratio. Okay, so I know that the length over here is 2 centimeters. And I need to calculate the size of the shaded area. Okay, so what am I going to need to do there? I'm going to need to use the area of a sector formula. So what was that again? It was theta over 360 times by pi r squared. Now I know that my angle I've worked out is 72 degrees. So let's just see if we could simplify that. 72 over 360 is the same as 36 over 180 if you just divide by 2, which is the same as 18 over 90, which is the same as 9 over 45, which if I divide by 9 is 1 over 5. Okay, so I can just make life easier by simplifying that fraction. You don't have to. So I know that so the area of the sector is going to be 1/5 times by pi r squared. And now I just need to work out what the radius is. So the shaded area is going to be the area of this whole sector minus the area of this little sector here. They both have the same angle, so I can multiply both of them by 1/5. So area of big sector is going to be 1/5 times by pi r squared. If the fifth thing is confusing you, just use 72 over 360. I just did it to simplify the numbers. 1/5 times by pi r squared. Well, this long radius here is 3. So that would be 1/5 times by 9 pi. So that would be 9 pi over 5. And the area of the small sector is going to be 1/5 times by the radius was 2. So 2 squared is 4, so that would be 4/5, 4 pi over 5. And how do I work out the shaded area? I do the big area, take away the smaller one. So I'm going to do 9 pi over 5, take away 4 pi over 5. Whenever you add or subtract fractions, they need to have the same denominator, so I'm super lucky that these do. And that would just give me 5 pi over 5. And actually, if I simplified that, that would just leave me with pi. And I could write pi centimeters squared. Okay, so in this question, I've been given a table and I've been asked to draw a cumulative frequency graph, and it's about the weights of 40 koala bears. So they're cute. Okay, so in order to draw a cumulative frequency graph, you need to actually find the cumulative frequency. So that can be the first thing that we do. And cumulative frequency is just the running total. So there are 5 koala bears. And actually, I'm just going to write it here so that it's a bit bigger because that's quite small. So the cumulative frequency is going to be 5 to begin with, because there are 5 bears between 0 and 3 kilograms. And then I add on 10, so that would be 15. And then I add on another 15, so that would be 30. And I know that there are 40 koala bears in total, therefore this must be 10. So my final cumulative frequency would be 40. Okay, cumulative frequency just means the running total, so you just add on everything that's come so far, because in total, I'm saying that between 0 and 12 kilograms, there are 40 koala bears. Now, to plot your cumulative frequency, you always use the end point of the class interval. So the coordinates would be 3, 5, and then 6, 15, and then 9, 30, and then 12, 40. And when I'm plotting, be really careful of the scale. Sometimes they're really nice, sometimes they're not. So just think to yourself, what's the difference between 0 and 5? Well, that's a gap of 5. And how many little squares are in between that? 10. So that means each little square is worth 0.5. So the first coordinate is 3, 5. So that would be 2.5. So 3 would be just 1 square up. 3, 5 would be here. Then I've got 6, 15. So 6 and 15. Then 9 and 20. So 9 and 20. And then my final one is 12 and 30. So it's a little bit of a, in the exam it will be a lot better. I had to make this quite quickly. So the graph isn't great, but we can still use it. So I've drawn the graph, and now I need to find the interquartile range. So with a cumulative frequency, and even with a box plot, you have your largest value, your smallest value, but then you have this section in the middle. So the median is always going to be 50% of the data. So there are 40 koala bears, so the median would be at 20. The upper quartile is the top, is where the 75% of the data is, and the lower quartile is where 25% of the data is. So to find the interquartile range, you are literally finding the difference between the upper quartile and the lower quartile. So we just do upper quartile, take lower quartile, and that will tell me the interquartile range. So what is 75% of 40? 3/4 of 40 is 30. So I go along to 30. Ooh. Hold on, something's not right. Oh, I should have plotted it at 40. Yep, so that would be a steep rise to 40. Okay, right. Anyway, interquartile range is 30. I go along the graph and then I go down. So let's just say that's 12.5. And then the lower quartile is going to be a quarter of the data. So a quarter of 40 is 10. So I go across to the graph and then down. So that would be 4.5. And the difference between 12.5 and 4.5 is 8. So the interquartile range is 8 kilograms. The next part of the question is saying estimate the number of koalas that may weigh more than 8 kilograms. So I'm going to use the other axes now, the weight axes, and I'm going to just mark a point at, that would be 7.5, so 8 is just going to be here. And then I go and I read across, and that is about 16. So how many koala bears weigh more than 8 kilograms? It's going to be all of these koala bears. Okay, so from 16 to 40, that's a difference of 24. So 24 of the koala bears weigh more than 8 kilograms. Okay, so this is an exact trigonometry question, and in order to work out your exact values, you just need to remember two triangles. So I won't go into the ins and outs of it, but this would be a triangle of side 1, this would be a triangle side length 2, and that would be square root of 3. So that is if you're using a 30-degree angle or a 60-degree angle. The one I'm interested in is a 45-degree angle, so I form an isosceles triangle that has 45 degrees. And the side length is 1 and 1, and this is root 2. If you want to know exactly how and why these triangles come about, watch the full video on exact trigonometric values. But for now, we're just going to go with this. These are the triangles you need to remember. So I am trying to work out sine 45. So if this is my angle, then I can label my triangle. This is going to be the adjacent, this would be the opposite, and this is the hypotenuse. How do I find sine? Well, sine theta is, if I write out SOHCAHTOA, always do that just to remind you, sine theta is the opposite over the hypotenuse. So therefore, in this case, the opposite is 1 and the hypotenuse is root 2. So the exact value is 1 over root 2. Next, I am told that cos 60 is 0.5. I could have worked it out using the triangles, but they've given it to me, so that's really nice. So now I need to work out the value of x. So this is just a basic trigonometry question. So SOHCAHTOA. I'm going to label my triangle. So this is my given angle. I'm trying to work out x. This is the adjacent. That would be the hypotenuse, and this would be the opposite. So which two sides have I been given? I'm dealing with the hypotenuse and the adjacent, so I would use CA. So I write out cos theta equals adjacent over hypotenuse, and it's really helpful to just write it out, just because the amount of silly mistakes you make under the pressure is mad. So just write things out and take it slow. So let's substitute what I know. I know that the angle is 60 degrees. The adjacent is what I'm trying to find, and the hypotenuse is 12. So all I need to do is say 12 cos 60 equals x. And you might think, this is a non-calculator paper. Yes, you'd be right. But that's exactly why they've told you that cos 60 has the value of 0.5. So I can rewrite that as 12 times by 0.5, because I'm just replacing cos 60 with 0.5. So 12 times 0.5, well, 12 times by a half is the same when you're multiplying by a half or 0.5. So times by 0.5 or a half is the same as dividing by 2. Just a quick little non-calculator exam tip. So x is going to be 6. And that's how I do that. Okay, so here I'm asked to prove algebraically that this recurring decimal has the value of 8 over 55. So I always start by calling my decimal x. So x has the value of 0.145, and the 4 and the 5 are recurring. What I want to do is keep multiplying it so that I get rid of anything that is not recurring. So if I multiply it by 10x, then I end up with 1.45 recurring. Now I've got the recurring part on its own after the decimal point, and that's exactly where I want it. And I need to multiply it by another power of 10 so that I also have another 0.45 after it. You can do this step by step. You know that 100x is going to be 14.54 recurring, so that doesn't match up. So you times it again. So 1000x is 145.45 recurring. And now you can see that you've got these nice bits where the bit after the decimal point is recurring, which means that if I subtract it, it will become 0. So over here, I can just circle my chosen values. I know that 1000x is 145.45 recurring. And I also know that 10x is 1.45 recurring. And what I can do is just subtract them, because if I subtract them, I get rid of this recurring decimal point and I make life very pleasant. So 1000 take away 10 is 990x. And 140, well, this and this is going to cancel. So 145 take away 1 is 144. So I could rearrange that and say x is 144 over 990. Now I know it's going to simplify, so let's just do what we'd normally do. Okay, so I've got 144 over 990. Now I just need to simplify. So I could start by dividing by 2. Whenever you're simplifying, you always try dividing by 2, then 3, then 5. You just essentially use the prime numbers. So let's try 2. 144 divided by 2 is 72. 990 divided by 2 is going to be 495. If you can't do that in your head, and just to be safe, you could just use the bus stop method. Just bus stop method is your favorite friend. Okay, so now let's see what I can divide this by. Well, I'm going to try 3. So 3's into 72, 3's into 7 go twice, remainder 1, so that would be 24. And then 3's into 495, 3's into 4 go once, remainder 1. 3's into 19 go 6, remainder 1. And 3's into 15 go 5. So that'd be 24 over 165. Now, what can I divide by again? Well, 3 maybe. So let's see, 3's into 165 is 3's into 15 go 5 times, remainder 1, and 3's into 15 go 3. So go 5. My goodness, what is going on with my mental maths? So that would be 55, and 24 divided by 3 is 8. Okay, so when you have a question like this, you need to prove it algebraically. So you do all the algebra stuff, but then you also have to show how it simplifies. It's not good enough to just say 144 over 990 equals this. You need to show the process of simplification, at least like simplify it once. And you also need to show what you simplified it by. So just take your time and double check everything and use the bus stop method to help you. Okay, so Dora decides to go on a road trip to the seaside. She lives in Cambridge. She leaves Cambridge at 8 a.m. on the Saturday morning. She drives 40 miles per hour for 30 minutes, stops at a service station to grab some breakfast. She's there for 45 minutes, then drives 60 miles per hour for 150 miles. I need to work out what time she arrived and the total distance she travelled. So what's the formula for speed, distance and time? Speed equals distance divided by time, and therefore distance is speed times time, and so forth. Okay, so let's figure some stuff out. So she drives for 40 miles per hour for 30 minutes. So I know the speed and I know the time. So I want to work out the distance. How do I work out distance? Distance is speed times time. So I do 40 times, and this is where so many people get caught out. Time also always needs to be written, unless the question is specifically meters per second or whatever, which it very rarely is. Always write it in units of an hour. So 30 minutes, and how do you write it as a unit of an hour? Whatever the minutes are, you write it over 60. 30 divided by 60, and then you simplify. So 30 over 60 is 0.5. So to work out the distance, I'm going to do 40 times by 0.5, and timesing by a half, remember, is the same as dividing by 2. So 40 times by 0.5 is 20 miles. So she drives 20 miles. She then stops at a service station to grab some breakfast. So there's two things I need to be working out. One is like the time. So I can set up a little column here. This is going to get a little bit messy. So time. And then I also need to work out the total distance. So the time, she leaves at 8 a.m. She drives for 30 minutes. So that will be 8:30 a.m. She then stops at a service station and is there for 45 minutes. So 8:30 plus 45 minutes is going to be 9:15 a.m. And then drives for 60 miles per hour for 150 miles. So in terms of distance, she travels 20 miles. Then she stops, so she doesn't travel any distance. And then she travels 150 miles. So the distance part is pretty simple. Total distance is 170 miles. And then I just need to work out the total time, which I can work out by using this. So how do I work out time? Let's just get rid of some of this. Time, if I rearrange the formula, switch these two around, time is distance divided by speed. So I have been given the distance, which is 150, and the speed, which is 60. So let's simplify that. Divide by 10 would be 15 over 6. And 15 divided by 6, once again, use the bus stop method if you're stuck. So whenever you know that it's going to be a decimal, you just add a bunch of zeros, put the decimal point down and add a bunch of zeros, and that's where your remainders go. So 6 is into 15, go twice, remainder 3, so I put my decimal point there, and 6 is into 30, go 5 times. So I know that that is 2.5 hours, which is 2 hours and 30 minutes. So 9:15 plus 2 hours is going to be 11:15, and plus 30 minutes is 11:45 a.m. So the total time it took her is it's not asking when she arrived, it's asking for the total time. So from 8 to 11, we go 9, 10, 11. So 3 hours and 45 minutes. And that's how we do that. So you just break up the question and work out each little bit by bit.